Hello, chat. Wow. Yeah, the card sorting robot does indeed function. Now, I cannot show you this, unfortunately, because I had to wipe the hard drive of the card sorting robot to do a separate school project, which means that it is no longer connected to my Wi-Fi network, which means that I can no longer SSH into it and, you know, do anything properly. So that's cool. Stream Elements bot running. Thank you, Stream Elements bot. You're very helpful. I appreciate the something. I don't appreciate much about Stream Elements bot. Okay, anyway, let's see, what was I doing? Oh yes, of course. Card sorting robot. So it works, yes. It sorts, it picks up the cards, it moves them around, and not very exciting to just tell you about it, so I have a video. A vidya, if you will. Let me get to this video. Alright, it's gonna make some noise. We don't want that, so I'm gonna close this before it loads. And then we go into the web browser and go to that link. Alright, and then we click this button. There you are. So, this is the card sorting robot sorting the cards. Wow. You can hear it. Very quiet. But anyway. So this is what works. I'll just leave that there while I talk. Let's see. Yeah, okay, so it works. Now, a few notes, it's slow. The card identification is fairly accurate, but it's not perfect. Like, it'll get the name right a vast majority of the time. You see, I moved from using eHash, perceptive hashes, to using SIFT, feature extraction, and Vlad vectors, which was much more accurate, we'll say. Wow, I am washed up. Anyway. Okay, but let me reconvene for a second and remember what I was going to say. Oh yeah, so it works, right? But one, look at it. The capacity is not very large. It's about the size of, it can hold 2 bins full. Actually, no, 3 of those bins can be filled, but it is also remarkably incredibly slow. And that is because I did not implement the algorithm that I wanted to implement. I wrote a very dumb and very bad algorithm instead. This is a card sorting algorithm. Basically, what I'm supposed to be doing is using a modified quick sort sort of deal. But instead of that, I'm using a, what's it called? Greedy dig sort, really, which is just horrendous. It basically finds the next card in the sorted stack, digs for it, and then puts it down, and then it finds the next card and then digs for it and then puts it down. So it's literally the worst possible sorting algorithm to use for this situation, but that's the one I put in because it was really easy to do. Okay, so because of this, we have a few changes to make. I'm going to probably my music. Oh, it just paused. Okay, I'm gonna mute this because I don't need that. Yeah, it's slow. Scanning is fairly accurate. Let's see what else. Let me remember what I was going to say. Oh yeah, it's slow. Doesn't hold that much. and my algorithm needs to be optimized. However, I do have a plan for the algorithm, which is not that important right now, but we can deal with that later. So basically, what is next? What is next for card sorting robot? I think what's next for card sorting robot could be, I think that just making a bigger card sorting robot doesn't really solve that many of the issues, right? Sure, it, you know, makes it hold more, and it lets it hold more cards, and then it can sort more cards at once. And it also gains efficiency in the fact that the sorting algorithm that I wish to implement gets more efficient the more bins there are. So, wait, wrong link. I tried to share the link of this stream to friends, and then it was the wrong link. That's okay. I will just send this. Okay, it's because it was the link to this card sorting robot video and not the link to the actual video I wanted to send. Anyway. What was I up to? Card sorting robot. What was I saying? Okay, anyway. Let me recall my statements. Right, I can make it bigger. Yeah, that's easy. Bigger means not that much faster. Well, it does get faster. It will be faster, just on account of having more target bins. The more target bins you have, the faster it is, but it can also hold more cards. But the more cards you hold, the less target bins you have, which means that it gets slower, and a lot slower. So how can we like optimize the number of target bins? Wait, is my mic going twice or something? Huh? How does that work? Wait, why? I'm not monitoring my microphone. Is it playing somewhere? This is muted. Hi Owen. I'm trying to fix my audio settings because I haven't streamed in months, and for some reason, okay, this should fix it, right? That'll fix it. Now I just need to figure out why is my desktop audio, where is it getting it from my desktop audio? Unless, is it going, wait, hold on. Voice meter, is it inputting it here anywhere? Why? What is it doing? Okay, so my music no longer works, but my audio, my microphone is fixed, so that's good. But why is why is my audio broken in the first place, huh? Where do I fix that? Okay, like it's not even showing in the... Here, let me pause my music. Boom. And then if I look at my desktop audio mixer plugin thing, it doesn't even show my microphone when I talk. So is it still broken? Does it still clone my voice? Wait. Okay, is it fixed now? Okay. It's fixed. Great, fantastic. Now, let me play my music again. Music is back. All right, wonderful. We're back, chat. Anyway, card sorting robot, it is functional. Yay! I want to make it better. And so, making it bigger can make it faster, basically. Oh, Halo's fun. Well, actually, I haven't played Halo, but I presume it's fun considering the amount of player base it has. Anyway, so we can make a card sorting robot bigger, right? That's the most obvious method. The other option is to decrease the number of cards that go into the robot, which is, you know, suboptimal, because how are you supposed to play video games? I mean, no, not play video games. How are you supposed to sort cards if you can only put in less cards at a time, right? How else can we make it faster? We can have batch processing. Basically, instead of sorting it discretely the entire time, like instead of, you know, sorting it continuously is actually the proper word. Continuous sorting. We sort it discretely into like 4 piles of letters, and then it's O of n instead of O of n log n, which is the other algorithm. So, I mean, lots of 25-year-old games are still peak. Like Melee's 25 years old. Well, it's gonna be 25 years old now, this year. That's crazy. But when am I coming back to Washington? I'll probably come. I'm not coming back anytime like soon. I'll probably be back in like this summer. I don't know. Maybe this summer, even. Like, I'm still going to be in Taiwan for the rest of the year. I'm not coming back this winter. But when I do come back, I'd like to bring the card sorting robot with me. Oh, you might visit Taiwan? That would rock. Well, if you visit Taiwan, you should do it before I don't know, sometime. Yeah, Stream Elements bot. I don't know why it's there, but whatever. Yeah, if you come to Taiwan, you should definitely come visit me. Because that would rock. Anyway, card sorting robot is slow. Yes, we already covered this. How do we make it faster? Batching. Batching is great. Basically, what you do is instead of sorting it, you know, by every single card. Ooh, my mic peaked. Why was that? Oh, you know what? Oh wait, no, never mind. Wait, is there? No. Okay. So, what was I saying? I don't even remember. Wow. Holy brain fog, chat. I did not get enough sleep. Anyway, where was I? Right, batching. So instead of sorting it discretely, we just sort it into piles. So like this one is in, so like we can just like determine like set mod 3 or something. Like if we have 3 target bins, we just like get the set from the TCG player ID, and then we convert that and we mod 3 that, and then that's the bin target we go into, and then it'll, you know, evenly distribute the cards based on the set. Or, you know, we mod 3 any like continuous value of the card, and then we have it in the three bins of output, and then, you know, that's 3, you know, divided up bins. This is basically what's it called, bucket sort. Or buckets. Instead of quick sorting, we will bucket sort. However, then you have to manually go in and do all the bucket sorting by yourself, right? So you have to go and run it a second time within that bucket to another bucket sort, and then that'll subdivide it further and further and further and further and further and so on. The machine is broken right now, chat. I broke it because I had to do another graduation. I know, not a graduation project. I had to do another final project, which involved using ROS 2, which is something. Yeah, I know, it's great, isn't it? Woo! So I can't show you, but it works. I can sort on, right now I can sort on anything that like TCG player provides. So like right now I can sort it by name, but as of right now, I'm just sorting it by TCG player ID because that's easiest, and it works really well. So I can sort it on pretty much anything that is included in TCG player's documentation. So like I can sort it on set and card number, which is pretty much the equivalent of sorting by TCG player ID. So I just do that, right? I can just sort alphabetically. I can sort by HP if I really wanted to. I can sort by attack 1 damage. I can sort it by alphabetical of the retreat cost if I wanted to. I don't know. I can sort it on literally anything, but I do not have the UI to do that. I have not built the UI to do that yet. So that will have to wait for another time. However, the robot has flaws. The first of which is that it's never actually finished a full sort before. It always gets stuck somewhere, and that's an issue of the hardware. It's because the one of those bins, you see the bin on the right, that white one? Yes, that's the camera bin. And the camera bin is printed in vase mode, 1 layer thick, basically. It's 1 wall, and it goes up. Now, because of this, I printed it, and my printer had some cooling issue or something. And so when I printed it, it became concave in some section of the bin. And so every once in a while, and this is not very common, this is maybe like, you know, once every 5 hours into the print, 5 hours into the sort, it will pick up the entire bin, not just a card. The entire bin will go with the grabber, and then it will jam into the bin to the left of it, that one that has all the cards in it right now, and then, you know, break everything. So that's really good. This is a pretty simple solution. The solution is don't design something stupid and idiot-like. So I will do that next iteration of this robot. This robot is not, I could screw that bin in, but you see, if you look at the arm as it pushes the bin in, the bin wobbles a little bit, and that's because the bin's not perfectly centered. And so if you it didn't wobble that time, but it wobbles every once in a while. If you screw the bin in, then it can't like wobble the bin to get it perfectly aligned with the grabber mechanism. It's built-in tolerancing, basically. It's very convenient. You can see the bin that is full of cards. If you look really, no, I guess you can't really see it. Never mind. It's hard to see, but the bin is not screwed in because it needs to wobble a little bit so that it is centered around the grabber and the cards can be, you know, picked up. I could just like put magnets in the bin or something and it'll fix it. Like I said, it's a really easy problem to fix, but I am out of white PLA, and PETG does not like to be printed with the thingy. So literally a rubber band could solve the problem, but I do not have the materials to do that, and I need to order that online, and I have not done that yet. Yeah. Anyway, so that's the current status of card sorting robot. Once again, how do we make it better? The first way to make it better, obviously, is by adding another axis, right? We only have the X and the Z right now. If we put the Y in, then hey, we've got, you know, another dimension of card sorting. Revolutionary. So then I was thinking, well, X and Y, right? Now you can sort like, I don't know, 1,000 cards at once. Each one of these bins right now holds about 220, I think I calculated. So how much was that? Yeah. So right now I can sort 3 bins at once about 660, right? So if I make it, you know, 3-dimensional, I can sort many more cards, obviously, right? Now, then I thought, what if if I make it a 2-dimensional, right? Then I can sort many more cards. Now, here's the consideration. What if you made it 3-dimensional, right? What if you could stack these bins on top of each other in some way? Then you can store all of your cards inside of this card sorting robot, and then you can you know, you can keep your entire collection inside of the card sorting robot and simply query it whenever you want a card, right? Like, let's say I want to build, I don't know, Pika-ROM, right? I can theoretically, I should be able to upload the Pika-ROM deck list to the card sorting robot. It should be able to, you know, grab those cards, put them into a bin, and then, you know, present that to me. Wouldn't that be great? And then I don't even need to sort the cards, right? The cards do not need to be sorted because the computer knows exactly where they are. The sorting is only helpful for the human who has to go and flip through them, right? So if you don't need to sort, and you only need to, like, you know, pick cards, then you don't actually need that much sorting capacity. You just need to be able to scan cards at a reasonable rate. And then you can load in bulk, pick the cards that are useful, and then, you know, get rid of the cards that you don't care about, right? So how do you do a 3-dimensional card sorting robot? Why did my music stop? Apple Music, you're throwing. Right, so how do you do a 3-dimensional card sorting robot? So you need a way to put these bins on top of other bins, right? Hey, Apple Music is goated, okay? Look, Apple Music has horrendous UI, and the UX is also horrible. But the actual quality of the music is goated. It's lossless, you know? Spotify doesn't even have lossless yet. Yeah. No, Apple Music is goated. Because, like, I can upload all of my random junk. I mean, you can do that on Spotify too, I guess. Nah. Spotify, I mean, I don't like Spotify because, anyway. So, card sorting robot. No, I use Apple Music just because it's chill. It's chill like that. It works. And, I don't know, it's got lossless. Spotify doesn't. That's all. That's literally it. I used to use Tidal, and then I stopped using Tidal. And now I use Apple Music. That's it. The entire everything else is worse, but... Okay, anyway. What was I doing? Oh, right, 3-dimensional. My beef on Spotify? I don't have beef on Spotify. It's just Apple Music does the job, you know? It's like, why change? This works. Right? And then, I don't know, I hear all of the weird stuff with Spotify, like the smart playlists and the, like, random, like, anti-consumer practice. Why is my microphone peaking? And the random, like, anti-consumer practices of, like, the limited skips or whatever. I mean, obviously premium solves that issue, but, like, do I want to support that, right? I mean, okay. Also, like, I'm not really interested in the whole, like, music discovery deal that Spotify has. All I care about is listening to my, like, I don't know, selected amount of songs, and then, like, that's it. Like, sure, maybe the correct workflow for me is just buying the albums and then keeping them in my library, right? I mean, like, I don't need to, I don't really, why is my microphone peaking? I don't really go out and look for music. I just, like, listen to the music that I already have, you know? But anyway, card sorting robot in 3 dimensions. How do you do a card sorting robot in 3 dimensions? Now, you could start by stacking the bins. Yes, that would be great. But then how do you pick up the bins? Now, this is where interesting things occur, and I can get back to my Firefox tab, and I can search for Ocado. Now, if you look at this, boom. Oh, that's really good. There we are. Oh, that's even better. Can I... Yeah. Okay, thank you. Pop up. All right, let's view this image. There we go. If you check out this image, you'll see that there are a lot of these square-ish robots on top of a lot of bins, right? Now, what's interesting about this, right? It's one, very easy to expand. It's really, really easy to expand. All you need to do is add more, you know, trays. And then these robots, what they do is they can lift, there's inside of these columns, I believe there are a bunch of different, wait, hold on. I believe that they stack the bins in there as well, and then the robots can pick up the bins too. Ocado bin. Here. There you go. This is a better image. Yeah. Can I see the image that I just clicked? No. Okay, anyway, oh, there's a pretty decent animation. Okay, there you go. So you'll see that cookies, yay. Okay, you'll see that the robot can pick up and drop the bins, right? Isn't that great? So I was considering, how do I do this, but it's cards? The real issue here is that it has to be the size of literally a trading card. And, hold on, what's the quote from the Iron Man movie? I think that's, the technology is ahead of our time. The real issue here is the drop down, this part that drops down and picks it up. There's no way to make that like rigid, which means that it's limited by, you know, gravity. And the issue with making things small is that you run into the square inverse law, or whatever it's called, where when you know, scale things down, the surface area is, you know, changed more than the like volume. Or no, the volume is changed, I don't know, one of them's changed. It just doesn't really work that easily. I need to use like tungsten or something to make it heavy enough. No, actually I probably don't. I don't know. Anyway, I was just thinking about this, and it was not very it's not a very practical solution for this, because it just is. All right, enjoy your event tomorrow. Yeah, enjoy. Have fun with your event. I'll see you later. I mean, maybe I should do a feasibility study on this, like, because maybe it's not that bad of an idea, right? Maybe it'll work. But yeah, I saw this and I was like, well, maybe there will be an issue with keeping the like drop down grabber, because like, how am I supposed to drop down and then like grab something, right? I need to like, because it all has to be flexible, right, to go down. But then how do I like trigger a mechanism to like spin? Do I need to drop down a servo motor alongside that, or do I need to like, I don't know, do I pull a cable? But then if you see, there's the issue is that every gram you pull, every newton you pull on that cable, you have to offset that with newtons of gravity in the actual grabber mechanism. And so it's like, okay, that's complicated. And I'm not really all that smart, so I didn't want to deal with that. So it's like, okay, this is a great idea. What if I didn't do it? So then I went into like, what if I did like an automated warehouse kind of deal? So you look here. forgot Google is useless. Thank you. Here, let's look at this. Accept my cookies, thank you. All right. Is there an image that I can see? Okay. Here's an image. It's not a really useful image though. Is there? Okay, that's also not a very useful image. All right, let's. Services. You know, maybe using this browser was not a great idea. All right, is there like? Nope, that's not very useful. I'd like a product. Ah, here. Wait. Let's open this into a new tab, although I think that's the one I was just visiting. Pallet shuttle racking system. There it is. That's what I was looking for. Yes. The pallet shuttle racking system. And it's gonna hide the image behind. Okay, look at this thing. What this does is it moves a pallet back and forth. Yes, that's right. This is the technological revelation that I was looking for. It's a little thing, it's a little platform that can lift up a pallet and move it forwards and backwards. But what if I just picked up cards? They're not that heavy, right? And I don't need to have like that complicated of a mechanism. All I need to do is pick up a card and then like, no, not pick up a card, but pick up a bin and move it left and right, right? So that's what, a servo motor, some IR sensors, and another motor for moving left and right. Right, that should be it. And then I need to, because that basically allows me to get one bin from one row. But how do I, that's one dimensional, right? How do I traverse the other dimensions? Now, a benefit of having things being small and not big is that the weight thing goes a different way, right? I can, instead of having to build like something really complicated, I can use a gantry and turn it on its side, basically letting me have a platform that moves in the Y and Z axes, and then it will, you know, the shuttle can move onto that platform, go to any other position in the warehouse, and then go into that slot, right? So now I can access every single slot in my three-dimensional card sorting robot with one gantry and one pallet mover. But I can always add more pallet movers. There's nothing stopping me from doing that, right? I can have 3 pallet movers. I can have 5 pallet movers. The only real limitation is the gantry. But I can also just expand in the other dimension, you know? I can expand so that the pallet mover itself has to move farther. Now, that'll also become a limitation in the future because you're gonna have to, every time you want to get one of the pallets in the back, right, you have to move the pallets that are in the front away from it, right? So if I want to move like bin C, but bin D, E, and F are in front of it, I have to move bin F, and then I have to move bin, you know, E, and then I have to move bin D, and then I can get bin C, and this becomes, you know, problematic slightly. So it can expand to a point, but also this is not that big of an issue because once you expand that far, it's like, do I really want to expand more? And you can always just add another gantry to like the left, for example. And the shuttle movers, since they can always move between the 2 gantries as well. They can go left and right. All right. So if I can always, you know, put gantries on both sides, and then I can approach the bins from both sides. And then if I, you know, want to grab one from, you know, left, I can get I can go through the left gantry, or if I want to grab one from the right, I can use the right gantry. The only issue is getting one from the middle, which is the same issue, but, you know, it's basically the same as doubling it. Anyway, so if that's the case, then where do I sort it, right? So I actually have something fun and cool and quirky that I can do right now. Check this out. I designed myself a little camera stand for my smartphone. And I believe if I click, hold on, let me place this somewhere. There we go. And I believe that if I click this button, there you go. Look at that. I'm a real streamer, chat. You get a hand cam. Wow! Now I can glove. Anyway, I'm gonna get degloved at the end of this. So we basically just need to have, you know, this is a side view, right? So this will be basically, so our bins will be sitting on top of whatever this is, right? So this, or this could be a bin, and then we have stilts, right? The bin sits on these side pieces so that the shuttle robot can move in the middle, right? So then it can move forwards and backwards. I don't know what my plan was. Like I was like, oh, I could draw it, but then I didn't really think about what I was gonna do. So did you know that I'm wearing the same headphones as Linus Tech Tips? That's funny, isn't it? Anyway. Yeah, okay. So what was I doing? Part sorting robot. Right. So we need to, if we pick up the bin, right? I mean, it's really, you can just explain it with voice. I don't really need to draw anything. But like, how are we gonna pick up the cards, right? I can, here, this will be a shuttle robot, right? We'll pretend that this is the same dimension. A trading card, which I do not have on my table for some inconvenient reason. Let me go and grab one. All right, so our bins will be slightly larger than our crocolore, right? But we also need to have these bins sit on a stand, which then means, so our bin dimensions, we're gonna call this one our bin, right? Our bins will be, I don't know, how wide is this thing? I believe it should be like 75 by 100 millimeters. Let's check. Because I know it's 63 by 88. So then if I round that up to, you know, 65 and 90, and then I add 1 centimeter in each dimension, then that's, yeah, okay. So the bins, oops, what happened to my, I think my pen died. Okay, that's okay. But basically, we are going to be making our bins, the bin size will be 75 by 100, right? And so the robot needs to be a little bit smaller than that so that we can have space for these stilts that the bin sits on. So I think our bin, we should just aim to make it be, I mean, the robot should be 65 by 90, right? Basically the same size as a trading card. So how are we gonna make this? How are we gonna make it this size? Wait. on. How big is an 18650? 18650s are like an 18650. Alright, 650. This is the diameter? Or is that the radius? Well, I can just Google this. $18,650. Okay, an 18650. 18 is the diameter. Let's do that. And then 65 is the length. Meaning it will fit within this box, right? I can put it, if this is the thingy, I can just put an 18650 right here. Yeah. And then power to, because that's, you know, convenient, it's 1S, right? Now we have a, or 1C, and what is it, 1C or 1S? 1C for one cell, right? 1S is like the charging speed. Let me Google that. 1C versus 1S. That's not useful. It's thinking I'm talking about a 3D printer. Battery. Yeah. Okay, 1S is, yeah, okay, so it's 1S. So this will be 1S. Now, to control the thing, we need to communicate with it wirelessly. And we need to do that in a small package, right? But luckily, we have these things called ESP32s. Wow. Now, there are ESP32s that include a BMS, which is what I'll probably be using because it's easier. So let me get the dimensions of that as well. Let me figure out where I can find that. I had Googled it and then I had lost it. Let me go and find it. It's the DF Robot Fire Beetle 2 ESP32. Let me Google this. There we are. Now, hopefully it's the right size. Blah, blah, blah. Okay. How big is this thing? Their dimensions. Okay. It's 25 by 60. 25.4 by 60 millimeters. This is 18. And so that means we can put it like right here. 25.4, right? Then we need to move it left and right somehow. And we also want to be able to do that. So this width is 65, 90. So let's say we put them next to each other with, I don't know, so that would be 30, 30, 40, 43.4 is the minimum width. So then if we add a, I don't know, plus 10 or just general, that's 53.4. Which is pretty much within our limits. So we are not horizontally constrained by those two parts, at least of right now. Now, how are we going to move left and right, and how are we going to lift this thing? Well, we can use servo motors. Let me go and grab one. I have a mini servo motor somewhere. Let me go and figure out where it is. All right. This miniature servo motor is, I don't know. Well, here, let's see how big it is. Where's my ruler? Check it out, chat. Ruler time. All right, it's, I don't know, 35. Not really, it's smaller than that. By, I don't know, 13. It's some size. Very helpful me, thank you. Okay, well, let's say it's 30 by 35 by, because we're gonna have to mount it somehow, so that takes extra size. So if this is 90 and this thing is 60, 35 is too big. But wait, is 35 too big? Now you see, we're not as constrained in the length department because of the simple fact that we can make it slightly larger than one bin. That's okay. The only real limitation is this horizontal width, right? That has to be within the 65. But the rest of it is okay. So can we mount this like this? Because what I can do is I can use one of them to drive. I can use a continuous servo as drive, and then I can use another servo on the other side, which would fit within the 65, I believe. Yeah, barely. I can have this one like this, and this will control the lifting mechanism. Basically, I'm just trying to make this thing as flat as possible because there's an important consideration we have to make. For every single bin in the system, we have to have the stilts underneath it, right? And so if we can make these stilts as small as possible, right, versus this, then our storage density is higher. Because our storage density is basically our bin size, right? The number of cards per bin. And then we have our stilt heights, right? Stilt. And then that's this is our height issue, right? We're gonna have the same X and Y dimensions, right? But the stilt height is what's important. I just saw a notification disappear. Was that me, or was that the website, or was that something important? I don't know. Well, whatever. Okay. Basically, that's the biggest thing that we need to do, is limit the vertical height to as small as possible. Now, something cool is that we can use really tiny bearings and just put them to the side, like out here. Then again, we have 18 millimeters vertical. So what if I just like put this vertical instead, right? But that would be a minimum of 30 for the like stilts, which is cringe and bad. So what if I had a smaller servo motor? What is the smallest servo motor that I can buy? There's apparently a 3.7 gram servo motor, which is absolutely tiny. It is 8.6 by 20 by 22 millimeters, which is, wow, that's insane. Okay, so it is 0.6 kilograms per centimeter at am I graduating? Yes, I am graduating this year. At least hopefully. I should be graduating. Of course, the school could be cringe, like have like some what's it called? A credit issue. I don't know. but theoretically, I should be able to graduate this year. It's so, this school's so obnoxious. It's really annoying to figure out what credits you're missing. Do I have any plans? Well, I'm applying to jobs right now. I got one take-home assignment from GM. But other than that, I haven't got anything else. Or I will apply to a master's program for robotics or something somewhere else. So the operating speed of this servo motor is really slow. Wait, hold on. Okay, at I don't know, at 4.8 volts, it is 0.09 seconds per 60 degree. That's not bad, right? That's pretty quick. I do not know what that number. So I just search for GHS37D. Copy. Oh, or search. There we go. I will order 2 of these because I need at least 2 of them. They're $5 each. Surely they are not that expensive. Like, surely that's not the right price, right? I need to log into this website. I need to copy this, log in here. You guys don't get to see my login flow, unfortunately. You can see my hand though. Wow. Paste. Search. Alright, is there a cheaper one? Then nope, 150 is the cheapest one they have. So I will just buy I'd buy 4 of them. I will buy 2 of them. I don't need to buy 4 of them right now. Check out. Okay, great. Let's deliver this to the nearby. Oh, okay, great. Place the order. There we go. All right, I've ordered my servo motors. They are the GH, whatever these are. So it is the dimensions of I'll draw a servo motor here. These are the dimensions. This one's 20. This one is 13. Oh wait, that's 22. 22. And then this one is oh, and this is 30.39. Okay, there you go. So this is a much better servo motor for our application, I'd say. Now, if I can convert this to be a continuous servo, theoretically. Yeah, there's screws. I can just open it. So wait, how do you convert a stepper motor or a servo into a continuous servo motor? Modification. Okay, there we go. Converting micro servos to or continuous rotation. Perfect. All right, so it should be pretty simple then. I mean, obviously I would rather not have to do that. So maybe we find another one or another way to drive it. I mean, like this should be fine for lifting the bin. Now, how are we gonna lift the bin? We have rotation, right? We have continuous rotation of, well, not continuous rotation, but we have rotation of 90 degrees. We have this, right? So how can we lift a bin with that? My first thought, and probably the thought I will try first, is I will have some sort of circular rotating mechanism, and from the side this mechanism will look like this, right? And then on the outside this is the bin picker upper. Now from the top it'll look like this, right? And then there will be pegs that go into there, so that when I rotate this circle, right, it will lift. I mean, it should be that simple, right? Surely it's not that complex. The other way we could do it is like with a generic like scissor lift mechanism or cam kind of deal, which, you know, would also work. Yeah. It should not be that difficult. I'm going to try this one though, because I can also put the pegs here and here, right? And then it's very stable. It's a real benefit. It's very stable, and also I can add teeth to this gear, right? And control it from outside. Of course, then this servo motor would also have to be, you know, the same diameter for what's it called? I don't know. Thingy conversion. Cool. Anyway, this is the idea. So yeah, all I have to do is do it. Well, I have to order the ESP32 and the battery, and I need to figure out how to wire the battery. Oh, and then I need to, right, I didn't tell you about how positioning. This pen keeps dripping. Doesn't normally do that. Well, I'm going to not use this because I keep dripping big drops. Maybe I'll switch pens. I will not use this pen anymore. Do I have any else inked up? Do I have any in it? Barely. No. This one? No. How about this? No. How about this? Oh, yes, perfect. How much though? Barely any. That's okay, I don't need that. Alright. So, how am I gonna detect where I am? So on the stilts, right? Never mind, it's out. Oh, this one. Does this one have any? No. Alright, let me go get my backpack. Alright, does this one have any? Yes, great. Okay. So basically the idea is that this is our stilt, right? Now, I think the way I'm going to do it is that the stilt will just be continuous, right? We're gonna have like so many bins here, gonna be another bin here, another bin here, another bin here, right? It's just gonna be one really, really long stilt. And so how are we gonna figure out where we are? Now, I was thinking, and I'm like, well, it's a very easy solution actually. All you need to do is have little infrared or reflective stickers where every position should be. So like, you know, mocap tracking and all that stuff, they use infrared and infrared reflectors. These things they're pretty common. And so I can just use an infrared sensor and just detect, you know, the presence of the dot. And it's really easy. Really simple. And then I know exactly where I am, and then I can just pick up the bin, you know? That's it. I spent more time finding a pen than I did explaining what the plan was. Yeah. So, that's that. What shall I do now? This is my keyboard. Wow, look at that. Ooh, we could do a bit of we could do a session of monkey type if you want. Let me get my Firefox. What's it called? Window capture. Existing Firefox. It's too small. I do need to make it a little bit bigger. Wow, isn't this great? What a great stream, huh? Why is it not working? It's still doing the CLS handshake stuff. Is it done now? No. I can't type in it. Alright, well, I guess this jank browser that I installed this jank browser I installed in order to get the correct theming does not work with monkey type, which is really cool. Well, that's okay, we don't need that anyway. You're just gonna go back to doing this. Bye-bye monkey type. Anyway, I do believe that's I can stop now. I think I described my plan well enough. Would you guys like to see the software? It's horrendous. I'll show you the software for the card sorting robot. Oh, you don't need to see this. You can use Firefox. github.com/card sorter. Wait, why is it laggy? Post. Why did it delete? It deleted more than 4. Ugh, that's annoying. All right, there we go. Okay. The last time I worked on this was 3 weeks ago, apparently. So here's how it works. We start at the hardware layer, which is It contains a durable CNC serial connection, which basically allows me to what the lag? Also, why is it light mode? Boom. No. Alright, maybe I should log in. You guys don't get to see the login. You can see this. Why is this browser so slow? You do not need to... I not remember my password. Oh, there we go. I remembered my password. It was a very bespoke and random one that I've not used in a very, very long time. Close. Okay. Here we go. I have been logged in. Why is it still in light mode? Oh, you know why? It's because my browser's deep light mode. There we go. Okay. Anyway, let us inspect this CNC serial file. I don't know. It's really, I don't know why I'm doing this. It's not that complicated. Basically, it just like does stuff. I don't know. Combs it. Yeah, okay. You know what? How about we figure out something new to do. Either we say, I think we can say we're done actually. I think I can say that. So thank you for watching. Let me figure out where my buttons are. Alright, yeah, thank you for watching. I shall see you another time. And maybe I will have a better plan next time too. That might be a good idea. Alright. Bye-bye.